Good morning. Today we will discuss about forecasting techniques, which is coming under Predictive Analytics. Introduction. Quarterly forecast of sales for one of our company's product over the coming 1 year period. So here we are going to choose one company and we are going to focus companies benefits. So here we are going to take production schedules, raw materials, purchasing, inventory policies, our marketing plans, and cash flows will be affected by the quarterly forecast. So the forecast can be either quarterly, monthly, or yearly. So when you choose any criteria to forecast, so that should affect the cash flow. So consequently, if you do poor forecast, it may result in poor planning and increased cost for the companies. So how should we go about providing the quarterly sales forecast? It is purely based on good judgment, intuitions, and an awareness of the state of the economics. Here, the forecasting can be classified into two ways. One is qualitative, another one is quantitative. So if it is qualitative, it generally involves the use of expert judgment to develop a forecast. And such methods are appropriate when historical data on the variable being forecast are either unavailable or not applicable. In case of quantitative forecasting methods, it can be used when past information about the variable being forecast is available. The information can be quantified, and it is reasonable to assume that past prologues pattern of the past will continue to the future. So whenever we have past informations, there we can try to go for quantitative forecastings. And again, these methods can be generally be divided into three groups. One is judgment methods, another one is extrapolation, another one is econometrics. These judgment methods will come under non-quantitative, and other two, extrapolations and econometric, will come under quantitative. So extrapolation models. Extrapolation models are quantitative models that use past data of a time series variable and forecast future values of the variables. So extrapolation, it is coming under quantitative. If it is quantitative, so we need to take the past data with respect to time. So time series data. So many extrapolation models are available, including trend-based regression, auto-regression, moving averages, and exponential smoothing. Some of these models are relatively simple, both conceptually and in terms of calculations required, whereas others are quite complex. All these extrapolation models search for patterns in the historical series and then extrapolate these patterns into the future. Some try to track long-term upward or downward trends and then project these. So sometimes it will be linear, sometimes it will be long-term and downtrends. Some try to track the seasonal pattern such as sales in November. So sometimes the company will try to provide a discount in some of the months. Some of the months it will be in peak. So based on that also, somehow they will try to track and they will try to forecast. So basically, more complex model, the more closely it tries to track historical pattern. When you have more complex model, it will be very close to track the historical patterns. So the goal of extrapolation models is to extrapolate historical patterns into the future. The potential problem with the complex model is that they can track a historical series too closely. That is, they sometimes track patterns that are really noise. So when it becomes so close, it may try to track noise also. So simple models, on the other hand, track only the most basic underlying patterns, and therefore it can be more flexible and accurate in forecasting the future. Now we will go for econometric models. It is also called as causal or regression based models. It uses regression to forecast a time series variables. Always we will go for time series because it is coming under quantitative. So there we need to have past data with respect to time. So time series data will be taken. The least square approach and the same multiple regression software can be used in many time series regression models. So the least square approach will help you to minimize the error when you forecast the values. So causal regression model for the time series data present new mathematical challenges. So by using econometric model, they will try to have some mathematical model with respect to time series data. A company to use a regression model to forecast its monthly sales for some product using two other time series variable as a predictor. So sometimes a product can be forecast in monthly basis. So for November and December. So in these 2 months, what about the sales? The sales will be forecast. When it goes to January, okay, the forecast will be different. So for some of the product in this regression, this forecast will be in monthly basis. So in econometric models, the resulting regression equations has the form prediction from regression equation predicted yt equal to a plus b1 x1t plus b2 x2t. Here y is the company sales in month, and the month is something, the t is a time, and x1t x2t are respectively the companies and the competitors advertising level in a month. So the regression models might provide some useful results, but there are some issues that must be faced. So we'll list out some of the issues. The first issue is that appropriate lags for the regression equation must be determined. The second issue is whether to include lags of the sales variable in the regression equations as explanatory variables. The third issue is that two advertising variables can be autocorrelated and cross-correlated. So what do you mean autocorrelations? Autocorrelation means a correlate with itself, and cross-correlation means being correlated with the lagged version of another variable. The company forecast is a general forecasting method that is worth mentioning. In fact, it has attracted a lot of attention in recent years. In many researchers believe that it has a potential for increasing forecasting accuracy. So to increase the forecasting accuracy, they will go for combining a forecast. This method is very simple. It combines two or more forecasts to obtain the final forecast. The reasoning behind this method is also very simple. The forecast error from different forecasting methods might cancel one another. So the forecasts that are combined can be of the same general times exploration forecast. For example, they can be a different type, such as judgmental or explorations. If we combine both, there will be different values. These values may be equally cancelled if there is any differences. The number of forecasts to combine and the weights to use in combining them have been the subject of several research studies. Although the findings are not entirely consistent, it appears the marginal benefit from each individual forecast after the first two or three is minor. So also, there is not much evidence to suggest that simplest weighting scheme is any less accurate than more complex weighting schemes. So most of the times, will always prefer simplest scheme. Why? Because there is no evidence that the simplest scheme giving less accurate than more complex weight schemes. The forecasting time series data. If the historical data are restricted to past values of the variable to be forecast, the forecasting process is called the time series methods, and the historical data are referred to as the time series. So everywhere the time is involved, so it is we are referring as the time series. The objective of the time series analysis is to uncover a pattern in the time series and then extrapolate the pattern into the future. The forecast is based solely on the past values of the variable and or past forecast errors. Forecasting methods are based on the assumptions that the variable we are forecasting has a cause-effect relationship with one or more variables. Here, if you look at these tables, so week details are given and sales details given. Continuously, almost 22 weeks are given. For 22 weeks, what is the sales? It is given. And the same for same table data, we have given here the graph. So if you look at this graph, so there is the variations. The variations was heavy, but at particular period after 11th week, that variation is very high. So we can see the differences. So by look at this table, the graph, we can understand what is happening in the beginning week, what is happening in the ending week, what is happening in the middle of the week. So where we have huge variations, where we have sudden variations. Okay. So this will help you to forecast our sales product. So the components of time series data. A useful graphical way of displaying time series data. These time series graph to help explain and identify four important components of the time series. One is trend component, another one is seasonal component, another one is cyclic component, another one is random component, that is the noise component. These are the four components. If you look at this graph, so each and every thing is graphically explained. First one is linear trend. The output is linear. Gradually it is increasing, and exponential, it is increasing, and slowly that y value is going to be increased, and the t value will be constant. And S shape, the shape itself will show as a S. Here it will increase, then there will be variations in the y shape. At the time t will be constant. T will be constant. Then the y will be constant and t will be increased. So this is the trend. The same way for seasonal component. See here we have taken seasonal, for example, for different months. So different months, what is the variation here with respect to time? Here may be November, December, January. Like that we have variations. For each and every month there is a sales product sales variations. So this variation will be given like that. It is a seasonal component only. The seasonal component with a trend. So the trend, there may be linear variations. Even though there is a variations in between the month, it will be in linear. So it can be explained in the form of linear component. That is a trend. It is a cyclic component only. There is a variation in y and t. It will look like a cycle. It will start from high value, then coming down, then go high value in the y, then coming down, then it is increasing way. The same way, if it is a trend, it will be slightly linear. So even though it is a trend, there will be variations in between. The randomization is a noise. So if you use the complex model, then there is a chance to get a noise also. So if you have noise, how it can be represented graphically? So this will be given different graphical manners the same way. These are all the formula for each and everything. It's a measure accuracies. For measure accuracy, we have different formulas. By using this different formula, we will be able to calculate the accuracy of the measures. Thank you.